Hello everyone, welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. So in today's lesson we are going to discuss about the Solidity compilation process. What are the nitty-gritties behind the compilation of a smart contract? We are going to talk about the EVM bytecode as well as the ABI and also look practically at the bytecode and ABI generated for our software smart contract which we wrote in our last lesson. Let's discuss about the compilation process first. So we have a smart contract and we save it with a .sol extension. Now, as we discussed in the last lesson, you mentioned the version of Solidity which you are using for writing the contract in your code itself using the Pragma directive. So using that version, the correct version compiler will be used, and the name of the compiler is the Solc compiler. We call it the Solc compiler, and the version will depend upon the version you are using in your smart contract. So reading by reading your contract, the version is known to the compiler, and that same version is used for compiling your smart contract. If the compiler is not downloaded, so in Remix you already have all the compilers available, but in case you are using the offline environment, then that compiler is first downloaded and then it is used to compile the code. So compilation means the compiler will create two files for your code. So one of the file is known as the ABI, which is application binary interface, and the other file is the bytecode. So we will be discussing about ABI in bytecode in detail, but for now you should understand that ABI means the context part and bytecode means the instructions part. This bytecode is further deployed on the EVM. So this is the whole process. So you write your smart contract in a high level language like Solidity, and the compiler uses the version mentioned by you and compiles it into two files. One of the file is an ABI file which is used for learning the context of your program, and the other file is basically machine readable instructions, binary data, which is then deployed on the EVM. So that's it for the compilation process. Now let's discuss about ABI and bytecode in detail. So let's discuss about the EVM bytecode. It's the executable code on the Ethereum virtual machine. So remember when we were discussing the features of Solidity, and we said that Solidity is a high level programming language, which meant that we write English like statements as code, which is mostly human readable. But since we need some medium for the machines to understand what you want the machine to do, for that we need to convert that human readable high level language to a very low level language. It is also known as the assembly language. So bytecode is that assembly level language. So this is what is not readable by humans, but it is understood by the machine exactly what are the steps which the machine has to take to execute your smart contract. So it's a low level programming language. So there are some subfields of this bytecode which is generated. We will be practically viewing this, but for now let me just tell you about all the subfields. So these are some of the subfields. There can be more additions to it, but these are the ones which are mostly always there in the bytecode. One is a link reference. So your bytecode will contain a link reference if your smart contract is dependent on the other smart contracts as well. So as we will be increasing the complexity of our smart contracts, we will be importing some other smart contracts into our smart contract. So our smart contract becomes dependent on them. So if in case there is a dependency, then you need to obviously know the location of that deployed, that dependent smart contract. So link reference is used to note that, okay, note the address of the dependent contract. Further, there is a subfield known as object. It contains binary data, bits and bytes, and you cannot interpret any information out of it. Humans can't do it, but for machines, it is a set of instructions that have to be performed according to the logic. Third is the opcode. So opcode is in between. So it's neither very high level nor low level. It's regarded as a human readable low level instructions. So I'll show you what opcode exactly is. To give an example, if you want to add two numbers a plus b, so here the operation is addition, and for that we use a fixed opcode which is add. Similarly for subtraction it's sub. So for all those instructions, some human readable instructions have been identified. They are known as the opcodes. So the exact list of opcodes is generated by the Solidity compiler, which tells the computer what order of instructions to be followed. Finally, we have something called as a source map, and it is used to map this instruction with the location in code. So source map, again, that's not human readable. When you will have a look at it, you'll understand. It's some mapping where that you are basically, the compiler is trying to tell you that this instruction is coming from this line of code. So there is a mapping which is maintained. Obviously, that is for the internal usage of the machines. We don't understand that, but this is very basic level of understanding what exactly a bytecode is. So this is what makes a bytecode complete. So there may be more subfields to it depending upon the complexity of your smart contract, but these are the most popular subfields which you will always find. Of this, the object is the main bytecode, actually, the binary data which we are discussing, that is the main bytecode, and opcode is some human readable instructions, while source map is the for identification of the location of the code. So let's talk about ABI now, application binary interface. ABI defines the methods and variables that are available in a smart contract. It enables application to contract and contract to contract interaction. So as bytecode is used by the machine to know exactly what has to be done. So basically bytecode is the instruction part. So we need some mechanism to get the context out of the smart contract also. So that context is provided by the ABI. So let me explain you by giving you an example. So in case you build a decentralized application, you design a front end in React or any framework, and you basically give a button which says mint an NFT, and you want that on the click of that button, basically your smart contract should be evoked, and that mint function basically should be evoked, and the NFT should be minted. But now for this to happen, for this interaction to happen, what is required is at the time of clicking the button, you should know what are the kind of inputs which is required by that mint NFT function. It needs the wallet address, it needs the ownership data, the access role, etc. So what are the inputs which that function requires, and you need to send those functions along with the call. And then you should also be prepared that what will be the output, whether it will be a boolean, true or false, whether it will be a string that minting successful, what are you expecting. So that context part, whether that means interacting of application to contract, or it could also mean one smart contract is interacting with the other smart contract. For example, for transferring of cryptocurrency, if you want to transfer some ether, so your smart contract needs to call another smart contract. But for that to happen, you need to know that what the other smart contract function requires. So for that context, ABI is important. ABI is basically represented with a JSON format. So JSON format means that a key value pair kind of thing. So we have an object, complete one object, where you have some keys and then the mapped values to it. So some of the important keys there are in the JSON format for ABI are the name, the type, the inputs mean the input parameters expected, the output expected, the state mutability. So state mutability we'll be discussing in detail in our upcoming lesson. Basically it means that whether you are trying to change the state of the variables or not. So this is about ABI. ABI is used for providing a context, and bytecode is the actual binary data which is deployed on the blockchain, and that is used by the machines to follow a set of instructions. So set of instructions along with the context together make a smart contract. So now let us also look at the exact ABI and bytecode generated by our program in Remix IDE. So as you can see, this is the contract which we wrote in our last lesson, the Hello World program. It's a very simple program, and let's try to compile it. So after we have compiled, you can see at the bottom here, you can see ABI and bytecode both. So basically you can copy them and see. Let's copy it. First of all, let's copy the bytecode. I'll paste it on a notepad here. So this is the bytecode generated for a very simple smart contract program which we wrote in a last class. So here you can see that we have something called as the source map, And this is the mapping of the instruction with the code, which we cannot make any sense out of it. It's totally machine readable. Now, second part, as you can see, this is the opcodes. So as I told you, some low level instructions, but these are still human readable. So there's a stack. EVM is nothing but a stack machine. So you have a lot of push operations, you have mstore. So these are all keywords which mean something. So these are the set of instructions. And how have these instructions been generated? They have been generated using this object. So object, this binary data. So this is the bytecode which we are talking about. Actually, this is the one which gets deployed on the blockchain. So basically, this is basically used by the machines to make sense. So the opcode, so these opcodes are generated using this. So there is a online, there are all those opcode generators are available. So if you will put this bytecode in that generator, you will see that exact same opcodes will be generated. So that is how you infer the opcodes. Link references are basically meant for the dependency, since our smart contract is not dependent on others. So this is blank for now. There are other things as well, but these were the important fields which we need to see. So now let's go and copy our ABI. Let's see how our ABI looks. So our ABI is a very simple one, because since our contract is not that complex. So it's, as you can see, this is a JSON object. A JSON object always begins with a curly bracket, and there are key and value pairs. So since let me show you the code. We only declared a variable known as hello world, and we saved a value. So if you can see here, so it will consider this as to be a function, because in ABI you convert everything to functions only, but the type changes, whether it's a constructor, it's a function, or it's a fallback, receive function, etc. So don't go into the detail of it, just have a basic idea how an ABI looks. So it's basically a type of function. That view means we're not changing the state, we are keeping it fixed, and we're just reading the value basically. And there's a string value, and the name of that variable is hello world. So all of this basic stuff. So it's giving the context. So you know that there is a function which has a variable named hello world. So you can write a more complex smart contract and then check its ABI to understand these things further. But these things are important, because knowing about ABI and bytecode would make much more sense when you are trying to build a decentralized application. Because then when you will be using JavaScript language to connect the front end with the back end, so it will ask for both the ABI and the bytecode as inputs. So there so a lot of people, they are confused as to why do we need to send both the ABI and the bytecode? Why is it even required? So for that to understand, I think this was very important for you to know that ABI will provide the context and bytecode will give you the exact instruction, and that is why both of them are required by the JavaScript library to connect the front end with the back end. So that's it for today's lesson. See you in the next one.